everyone, this is my first video on YouTube, and with this video I would like to teach physics to the students of class 12, and I hope I will be able to explain you the chapters in the easiest way possible. So let us start first with electrostatics. So this is the first unit of class 12 physics, and it consists of two chapters: electric charges and fields and electrostatic potential and capacitance. First of all, before starting the first chapter, let us understand what is the meaning of electrostatics. Electrostatic is the branch of physics. It is the branch of physics which deals with charges at rest. So it deals with charges at rest. So there is another branch of physics which is known as electrodynamics. Electrodynamics. Okay. So it deals with charges in motion. Now, this charges at rest gives rise to electric field. And charges in motion mainly gives rises to magnetism or gives rise to magnetic field. Okay. So, or it deals with electromagnetism. We shall deal with this thing later. So charges at rest, mainly charges at rest will always develop only electric field. Remember this. So now, before going to electric field, let us understand what is charge. So now we all are aware of static electricity. Static electricity. So we all know static electricity is the electricity that develops due to friction when two bodies are rubbed against one another. So static electricity develops when two bodies are rubbed against one another. That is due to friction. That means, and when two bodies are rubbed against one another, they are said to be electrified. They are said to be electrified or charged. So whenever we say electrified or charged, then the concept of charge comes. What is this charge? So we should know what is the concept of charge. Charge is the intrinsic property of a substance which gives rise to forces of attraction or repulsion. Okay. So now, what is the meaning of intrinsic property? Intrinsic property means a quantity, means a property which is independent of the amount of mass present in the substance. Okay. Like mass is also an intrinsic property of a substance. Unlike mass, charge or mass, both are intrinsic. Okay. It does not depend on the quantity of matter present. Now, unlike weight, what is weight? Weight is an extrinsic property because it depends on the strength of the gravitational field. Okay, so this is the difference between mass and weight, and charge and mass are same. Now, how do you represent charge? So charge is represented by, your charge is represented by coulomb. Means it is a charge is represented by C. Coulomb is the unit of charge. Okay, so you have to remember this. And now the question is, how many types of charges are there? So we all know the charges are of positive and negative. But before this conclusion was reached that charges are of two types, before charges were known to be only of like and unlike type. Various experiments were done before to understand the nature of the charges. First of all, let us see one experiment. It was seen that if you take a glass rod, okay, this is a glass rod, and you take silk, okay, and you rub the glass rod with silk. Now you bring another glass rod and rub it with silk again. And now if you bring these two rods near each other, it was seen that these two rods repelled each other. Now you take a plastic rod rubbed with fur and you bring another plastic rod rubbed with fur. It was seen that these two bodies repelled each other. That means it was understood that maybe these two possess the same type of charges, that's why it showed repulsion. Now, suppose if you take a glass rod rubbed with silk and a plastic rod rubbed with fur, these two attracted one another. Okay, so that means again it was concluded that there are different type of charges in these two bodies. Now what was concluded that many other experiments also were done, with pit ball also experiments were done. So it was concluded that some type of charge developed due to rubbing, okay, and the charge that developed on the glass rod was positive in nature, and in silk negative charges developed, and in plastic rod negative charges developed, and in fur positive charges developed. That means the charges were named as positive and negative. So now we understood that means there are two types of charges, namely positive and negative. And another property was concluded that like charges repel and unlike charges attract. This conclusion was made. Now there was another theory known as electron theory of electrification. So here it was said that whenever two bodies were rubbed against each other, only the electrons from the outer shell of the electrons could only move. Okay, so electrons were the ones to move. Okay, and electrons move from one body to another. Okay, this was the electron theory of electrification. So now let us move on to conductors, insulators. So we all know what are conductors. Conductors, insulators and semiconductors. So we all know that conductors are substances through which charges charges can flow very easily. Okay, and here electrons are the charge carriers. Electrons are the charge carriers. And insulators, there was no conductivity. Okay, this would not conduct. There are no charge carriers. No charge carriers. And in semiconductors, semiconductor could partially conduct. Okay, here electrons and holes. We will come to know what are holes. So later. So electrons and holes are the charge carriers. Okay, so electrons and holes are the charge carriers. So, and another property of semiconductors is that its conductivity can be increased or decreased by adding impurity. We shall deal all these things later. So as of now, we all are aware of these properties of conductor, insulators and semiconductors. Now let us move to some of the properties of charges. Now let us deal with some of the properties of charges. So first of all, let us know what is quantization. Quantization of charge. So quantization of charge. So what is quantization of charge? In quantization of charge, it is said that charges always exist in discrete packages. Okay, charges always exist in discrete packages. Okay, and suppose the total charge of a body is Q, and Q will always be written n times of E, where E equals to charge of an electron. Okay, charge of an electron, and this is the smallest unit of charge possible. Okay, so this is the charge of an electron and this is the smallest unit of charge possible. Now, all existing charges in nature are found to be n times of E. N can be any value from 1, 2, 3 and so on. N cannot be like this in fractions 1.5 or 1.7 or 0.3. N cannot be in this form. Okay, it should be integral multiple. So this is one of the properties of charges. The charge is always quantized. Charge always exists in discrete packages. Okay, this is one of the important properties of charges. Another important properties of charge is that charge always exists in another important property is additivity of charge. Additivity of charge. So you know, charge is a scalar quantity. Okay, charge is scalar quantity. So the total charge of a system can be the sum of different individual charges. Suppose this is a body. Let's charge 1, 2, 3, 4, 5 and total charge is Q. So you can take the total charges, suppose Q4 plus Q5. So you can easily add the charges. Okay, so this is the additivity of charges, and you know charges are scalar. Charge is a scalar quantity. So always remember this, charge is a scalar quantity. Okay, so this is additivity of charges. Now let us see what do you mean by conservation of charge. Conservation of, what is the meaning of conservation of charge? Charge is always conserved. That means if you take a glass rod and if you take a silk, okay, so the total charge before rubbing, okay, and the total charge after rubbing will be same. That will, it will be conserved. Okay, so the total amount of charge, according to its definition, it means that the total amount of charge in an isolated system is constant. The total amount of charge in an isolated system remains constant. Okay, so what does it mean? And what is the meaning of isolated system? Isolated system means this is a system. Okay, so it is not under the effect of any force. Okay, this means an isolated system, the system which is not under the effect of any force. So if a body is not acted upon by a force, then the charge will remain conserved. It will not change because charge can neither be created nor destroyed, but can pass from one body to another. Okay, so you have to remember this. This is the main statement of conservation of charge. Okay, so the here before rubbing, okay, and after rubbing, the charge will be, the total charge will be same or neutral. Okay, before it was neutral, after rubbing also, okay, it will be neutral. Okay, the same that if you sum total all the charges, it will be neutral. Okay, so this is all about conservation of charge. Next topic for us is electrostatic induction. Electrostatic induction. So now, before understanding what is electrostatic induction, let us see what is electrostatic. What do you mean by charging by conduction? So conduction means, suppose you have a charged body, suppose you have a positively charged body, and if you touch an uncharged body, so this was previously uncharged, so if you see that after some time it will also become positively charged. Now how did this happen? When you take a positively charged near this charged body, what will happen? The negatively charged will be attracted towards this end and will pass on to this charge, and when electrons will pass from here to here, it will become positively charged. So this conductor becomes positively charged. So now that is, we can say that when an uncharged body is charged by touching with a charged body, then this is known as charging by conduction. Okay, charging by conduction. Now we shall understand what is charging by induction method. So here what happens is that suppose suppose you take an uncharged body. Okay, suppose you take an uncharged body and you bring another positively charged body near it. Okay, so what will happen? The negatively charged particles will be attracted towards this end. Okay, will be developed towards this end, and the other end will have positive charges. Okay, now if you keep the same setup, this is a stand, and you keep the positive body as it is, so these are all the negative charges and positive charges. So now if you touch this body with your hand, what will happen? All the positive charges will pass through your hand, okay, and reach the earth. Okay, so next what will happen? If you now remove this charged body, what you will see? You will see that this uncharged conductor, this positively charged particles will all move. So now what is left? All these negatively charged particles, and so this becomes negatively charged conductor. Okay, so this is how charging by electrostatic induction occurs. Okay, so this was how a body was static induction. This was how a body was charged by electrostatic induction, that is without touching. You can see this body is not touched with this body. So without touching these two bodies, you could charge it with a negative charge. By bringing a different type of charge, you could charge, by bringing a positive charge, you could make it negatively charged. So this was all about electrostatic induction. This was the introductory part for today. In the next class, I shall deal with Coulomb's law and electric field and various applications of electric field. Thank you. I hope you like this video and do give me feedback. Thank you.